create geometry for this 2D flow problem and then solve it in Fluent, start with Analysis Systems, Fluid Flow, Fluent, and drag that to the project schematic. Okay, so here's your workflow. First thing to do is geometry. If you left-click it, it's a bunch of options. The only one that's important here is Analysis Type. You want to set that to 2D. You then right-click the geometry and select New Geometry. It's going to open up a program called Design Modeler, and we want the units to be millimeters because what we're working with is quite small. Okay, first thing is select the XY plane there. You're not actually looking at the XY plane, but if you want to look at the XY plane, click on the blue arrow here in this thing that's called the triad. Now, although these are labeled X, V, and W, if you hover over the arrow, it'll tell you what it is. The blue one is plus Z, meaning that if you click on that, what you look at is the XY plane. Now, highlight the XY plane and go up to here. It says New Sketch. That's exactly what we want. All right, so to do all of our drawings, we need to go to Sketching here. And we want to have a rectangle that is going to be our flow channel. Now, before drawing that, what you're going to want to do is go to Settings and look at the grid. And you're going to want to snap to the grid. Major grid spacings here are 10 millimeters. Minor steps are 10 per major. So that means you will snap to some locations that are separated by a millimeter. The snaps per minor is 1. Okay. Go back up here to Draw, select the rectangle, and hover over there, and then look in the lower right-hand corner and make sure that you're on 0, 0. And then drag to another point, and you have a rectangle. The size of it is wrong, but that's okay because we're going to fix those dimensions. Zoom to fit. We'll zoom in on what you just drew. When you select Dimensions, General is the default. Grab one of the edges and drag either to the left or up, some arbitrary direction. Now you can actually specify the dimensions. We want this actually to be 7 millimeters long, 0.7 millimeters high. And let's zoom to fit again. Okay, so that's actually pretty good. Now, what we want to draw next is a circle that is going to be basically cut out of the flow channel. It's going to be an obstruction. That's going to give us some interesting flow behavior. Now, a highlighted circle, and look at the lower right-hand corner. So I'm going to snap to a location that's like at 3 millimeters and 1 millimeter. Even though I'm on top of this thing here, it's just frankly going to be off if I went ahead and did this. In fact, it won't even let me do it because I'm so far away from the grid point. Okay, there it is. See, that's not good at all because the center is not aligned with our top line there. So that's useless. Right click, back. That gets rid of that. Now, here's the trick. We want the circle centered at the point 3.5 millimeters in the x direction and 0.7 millimeters in the y direction. In order to get there, one thing that might be helpful is to turn on the grid. So we see that that point of interest, which is right here, is nowhere close to being in the grid. So what can we do about that? Well, just change the grid. Now, minor grid spacing, change that to 1. Sorry, major grid spacing of 1. We still have 10 minor steps per major and 1 snap per minor. what this means is that now when we go to the circle here, the point 3.5, 0.7 is actually valid. You click it. You can either click and hold and drag, or just click and then move your mouse, and we get a circle. So we didn't really worry about what the radius was, because we're just going to go to dimension here, and we're going to right click or left click on the edge and drag inward, and now we've got a constraint. And you look here, we want the diameter to be 0.5 millimeters, and there we have it. Okay. Next step. Next step is to turn this into a 2D face and get rid of the lines that we don't really care about. Before we do that, let's look at what happens when we change the constraints. So for example, let's double this size. Now one neat thing is that the circle is automatically constrained to be on the upper edge. So it moves with it, at least in the y direction. However, if we change this, the circle doesn't actually move in the x direction. That's basically just a default behavior. And by introducing something called a constraint, you can, in fact, change the behavior of how, when you change dimension of one of your objects, that affects the position and even the size of your other object. We won't get into that because we don't need it. So what we're going to do is go to Modify, and we're going to now trim. Okay, so we trimmed off that whole line, that half circle there. It looks like we didn't trim this off, but that's actually part of the constraint. The line's gone. The other lines that we want to get rid of are this one and this one. So now we basically have one continuous path that can define the 2D flow area. If we go back to modeling, we've done all of our work on this thing called Sketch 1. The last thing to do is to do a surface from a sketch. And we're going to highlight Sketch 1. Go down here. These are the details of the operation we're working on, which is Surface Sketch 1. Here, details of Surface Sketch 1. And we need to select a base object. And you hit Apply, and one sketch is what you get. Notice here that you've got this lightning bolt. The lightning bolt means that, in fact, you need to click the lightning bolt up here in order to carry out the command. Okay, so there you go. There's our face. And we are, in fact, done with the geometry. We can click Save. And we're going to call this Intro 2D version 3. And we will move on, but